Welcome back. Let's continue with chapter 4.4 Intermolecular Force. So basically we are going to discuss three intermolecular force in this topic. First, dipole-dipole forces, London forces, hydrogen forces, and then discuss what are the factors that will going to influence the strength of these forces, and then how they are going to influence the boiling point, solubility, and also density. Let's start. What is the meaning of intermolecular force? Basically, the term inter is represent between. Okay, so let's look at the diagram here. We have two lines here. One is a solid line, okay, with label A, and one is dotted line with label B. Okay, so generally, if a bond in between two atoms, we generally will know this as covalent bond. While this attraction, which represented by dotted line B, are the attraction between two molecules. So that's why we will know this as intermolecular attraction. So between this covalent bond, or sometimes we also can know this as intramolecular force. So between this intra and intermolecular force, which one is stronger? Yes, you are right. Covalent bond is stronger compared to intermolecular attraction. So that's why I come in a simple conclusion. Generally, intermolecular force is weaker than intramolecular force. Generally, there are two types of intermolecular force. One is van der Waals, while the second one is hydrogen bond. Then, under the van der Waals force, it can be divided to two forces again. One we know as dipole-dipole interaction or permanent dipole, and another one is London forces, which known as dispersion forces as well. Let's proceed to tutorial question number 1A. What are the dipole-dipole forces? Because this question is what asks us what. So that's why we can directly consider this is a definition question. Okay, so that's why we could say that dipole-dipole forces are the attraction force between the neutral polar molecule. So if you still remember in the tutorial video, we've already been discussed dipole-dipole forces is permanent forces or permanent dipole. So why the dipole is permanent is because of the different electronegativity. So if different electronegativity, it may cause the molecule become the polar molecule. Now let's proceed with question 1C. Then now we are going to look at what's the difference between London forces and also dipole-dipole forces. Okay, let's see this table. Like just now we already mentioned, dipole-dipole forces are permanent dipole. Okay, so that's why here this is permanent. While for London forces, it is temporary. Okay, because the electron is moving all the times. Okay, so between these two forces, we will know that generally dipole-dipole forces are stronger. However, there are a few factors that will influence the strength of each of these forces. For example, if for the London, we will depend on the relative atomic mass or relative molecular mass. While for the dipole-dipole forces, the strength is depends on the dipole moment. Okay. Now return back to question number 1B. Okay, this question is different from question number 1A because this one is asked us to explain how. So that means there will be longer. It's not definition question. So look at the diagram here. We will notice that the electrons are average distributed between the non-polar molecule. However, because the electron is always moving, so at any instant or at any point of the time, the electron distribution might likely produce a dipole moment. For example, in the diagram 2 left here, this is partially negative because the arrow pointed to the left side, while the right side here will be partially positive. Okay, so at this moment, then what will happen? The molecule A will induce, okay, we will use the term induce the molecule B, okay, and a temporary dipole can induce, or we use simple words to understand is influencing the electron in the nearby molecule. Then it will cause a dipole. So at this moment now here, the London forces is formed. So London forces exist in all the covalent compound, and then the strength of the London forces will be depends on the size. Okay, this is the first factor, and then second factor is the shape. The larger the size, the stronger the London forces. While for the shape, linear shape consists of greater or higher, bigger contact surface area. Therefore, the London forces also will be stronger. Let's look at one PSVM question. So explain why the boiling point of chlorine is lower than bromine. So if the question asks us about the boiling point, there are a few steps that you have to follow. For example, first step, we are going to identify the type of compound. So both chlorine and bromine, as we know, they are elements from group 17 halogen. So they are going to form covalent compound. After we know that they are covalent compound, generally step number 2, we are going to determine the polarity of molecule. Either they are polar or non-polar molecule. Since the electronegativity are similar, so in this case, both chlorine and bromine are non-polar molecule. So if they are non-polar molecule, so we know that the type of intermolecular force basically will be only London forces. As just now we already discussed, London forces, the strength of London forces affected by two factors, which are molecular size and also the shape. But because of we know that the Lewis structure of chlorine will look like this, which is linear. Same case also will happen to the bromine, also linear. So therefore, in this case, we are going focus on the molecular size. Okay, next question. Which has higher boiling point? Pentane or 2,2-dimethyl propane. So at the left hand side here is pentane, and then at the right hand side here is 2,2-dimethyl propane. From the name, we know pentane contains 5 carbons. 2,2-dimethyl propane also contains 5 carbons. So we apply what we discussed just now. Step number 1, basically we are going to identify the type of compound, in this case, which is covalent compound. Then next, because they are non-polar, the bond between carbon and hydrogen is considered of non-polar bond, so the molecule is non-polar molecule. Due for non-polar molecule, so the intermolecular force between the atom will be London forces. And then London forces, the strength of London forces are affected by the size. But just now we already identified both of them have 5 carbons. So that means in this case, it is not affected by the size. There will be another one is affected by the molecular shape. As we know, linear shape, they will have greater contact surface area. Okay, so when they have greater contact surface area, means that the strength of the London forces will be stronger. London forces will be stronger. So that's why in this case, which has the higher boiling point? Pentane, because pentane is linear shape. Okay, now continue with the question D. Describe the hydrogen bond. Hydrogen bond is an attractive force between hydrogen atoms in a polar molecule with a neighboring electronegativity molecule, okay, or ion, which has a unshared pair of electrons. Also usually will be found at fluorine, oxygen, or nitrogen on the other molecule. So based on here, for example, if I have a hydrogen here and then this is fluorine. Okay, so this is one molecule. And then let's say here have another one molecule, so will be hydrogen and fluorine as well. So a hydrogen atom, okay, so this is a hydrogen atom, okay, and then with a neighboring electronegative molecule, so this is neighbor molecule, okay, so this neighbor molecule have fluorine, which consists of an unshared, at least one pair of unshared electron. If we look at here, fluorine have 3 pairs, okay, so there is at least one unpaired electron, which is usually fluorine, oxygen, or nitrogen. So this is hydrogen bond. Okay, proceed with tutorial question number 2. Name the type of van der Waals force. So very obvious, all the following compounds here are covalent compound. Okay, because the question already asked us to identify the van der Waals force. Okay, then we know that van der Waals force have 2 types. One is London forces and then another one is dipole-dipole forces. As we already know, generally, first we are going to determine type of compound, which is covalent. Second, we are going to check whether this molecule is polar or non-polar. So if we want to determine the molecule is polar or non-polar, means that we are going to draw the Lewis structure. After we draw the Lewis structure, for example, A, nitrogen. So we know this is the Lewis structure for nitrogen. Then because of here, both are nitrogen and they have same electronegativity, therefore this molecule is non-polar molecule. So if non-polar molecule, so the intermolecular force will be van der Waals, and then is under London forces for nitrogen. So if continue with the boiling point, then we are going to compare their factor, which is the size of the shape. The next structure is SO2. Sulfur has 6 valence electron. Oxygen also has 6 valence electron. So total is 18 electron. In this case, sulfur is central atom. Both oxygen are terminal atom. As there are 2 terminal atoms and each terminal atom achieve octet, so we are going to minus 16. So it means that we have 1 lone pair electron. So in this case, we already fulfill the first part. We know that it is covalent compound. So second, because there is lone pair electron, so this SO2 is considered as polar molecule. So then the type of intermolecular force is van der Waals force, and because this is polar molecule, so both London forces and dipole-dipole forces are present. Next question is CCl4. As usual, we are going to determine the type of compound, which is covalent compound. Then next, we are going to draw the Lewis structure to check the polarity. So carbon has 4 valence electron plus chlorine 7, so total is 32 valence electron. So as from the formula, we know that there is 4 terminal atoms. Each terminal atom going to have 8 electrons. So 8 times 4, 32, means that there is no extra electron. Okay, so means that there is no lone pair in the central atom, so this is non-polar molecule. Since it is non-polar molecule, then we will going to know the intermolecular force for this non-polar molecule is only London forces. Structure D, again, only consists of hydrogen and sulfur, so this compound is covalent compound. Next, we're going to draw the valence electron. Hydrogen have 1 valence times 2 plus sulfur 6, so total is 8. So as we know, there are 2 hydrogen atoms, so that's means minus 4. So here we have 4 extra electron, means 2 lone pair. Since this compound has lone pair, we use a quick way. Molecule which consists of lone pair electron will be considered as polar molecule. So because this H2S hydrogen sulfide is polar molecule, so both London forces and dipole-dipole forces are present. Next one is C6H6, which is the benzene. So as we know, element consists of carbon and hydrogen. The bond will be considered as non-polar molecule. So because it is non-polar molecule, so we only London forces are present. Last question for question number 2. Again, based on the formula here, nitrogen and fluorine both are non-metal, so they are going to form covalent compound. So next we are going to determine the polarity. Nitrogen have 5 valence electron, fluorine have 7, so total we have 26 valence electron. With 3 terminal atom, basically we will going to minus 24, so have 2 extra electron. So as this molecule consists of lone pair electron, so we will consider NF3 is polar molecule. So if it is polar molecule, so the intermolecular force present between the molecule are London forces and dipole-dipole forces. Okay, question number 3a asks us to give the factor that will influence the strength for the van der Waals force. So to keep in mind that always we have to check the polarity of the molecule first. If the polarity are similar, then we will look at the size. If the size is similar, then only we will look at the shape. So please do remember that the stronger the intermolecular force, the higher the boiling point, because we need more energy to overcome the intermolecular forces. Now let's proceed to question number 3b. Which of the following molecule has higher boiling point? So as we look at here, Br2 will be considered as, because they only consist of non-polar bond, so this molecule will be non-polar molecule. While ICl, because iodine and chlorine has different electronegativity and there is only one polar bond in the molecule, so automatically this molecule will consider as polar molecule. Next, because of polar molecule, ICl will going to form strong dipole-dipole forces. Okay, while for the bromine, because it is non-polar molecule, so only will possess London dispersion force. And here, because we want to compare the boiling point, so we have to compare the strength of the intermolecular force. So dipole-dipole forces, here I already mentioned, is stronger than London dispersion force. Therefore, ICl has a higher boiling point. 3b2 now is comparing the boiling point between Hi and HBr. As this time we notice that the bond between hydrogen and iodine is polar bond, and between hydrogen and bromine also considered as polar bond due to different electronegativity. Therefore, we can say that both are polar molecules. So if you still remember just now we say if they have same polarity, next we are going to compare the molecular size. So when you look at here, iodine is at the bottom of the periodic table compared to bromine. Therefore, we know that the size for iodine is bigger. So if you look at here, they will mention that hydrogen iodide molecule is bigger. So therefore, they will going to form stronger van der Waals forces. Because both are polar molecule, so both consist of London forces and also dipole-dipole. So in this case, we can directly use van der Waals force. Proceed with 3b3, hydrogen fluoride and hydrogen chloride. So when we look at hydrogen fluoride, we will have the idea that hydrogen bonded to FO or N has the possibility to form hydrogen bond between molecules. Okay, so in this case, you can see that hydrogen bond is stronger than van der Waals force. So that's why here they say that HF has higher boiling point compared to HCl because hydrogen fluoride able to form hydrogen bond. While for hydrogen chloride, because it is a polar molecule, so it will form van der Waals force. Okay, so hydrogen bond is stronger than van der Waals force. Okay, let's recall again what we are going to do when we want to answer the question related with the intermolecular force. First, we have to check what is the type of compound. If it is covalent compound, next we are going to check their polarity. If their polarity is polar molecule, basically we have to check is that hydrogen bond will be present. So how are we going to check hydrogen bond? Make sure that there is hydrogen and then the hydrogen atom is either bonded to fluorine, oxygen or nitrogen, which we always mention hand bond. Okay, if yes, that means hydrogen bond are present between the molecule. So the next thing in the hydrogen bond, the strength of the hydrogen bond, the priority will be given to the electronegativity and then followed by number of hydrogen bond. So as we already know, the most electronegative is the fluorine, followed by oxygen, and the least electronegative among these three is nitrogen. So now let's look at tutorial question number 3C. Ethanol and methyl ether have same molar mass. But then why? Which of the molecule has higher boiling point? So if we go through this question and we draw the Lewis structure for ethanol, consists of two carbon, and then each carbon will going bonded to 4 bonds. So CH3 and then CH2 O bonded to H, and then the oxygen with 2 lone pair. While for the methyl ether, the Lewis structure is look like this: CH3 connected to O and then CH3. So when we look at these two structures, you will notice that ethanol consists of hydrogen and then is bonded to oxygen. While for the methyl ether, all the hydrogen are bonded to the carbon, which is not in the list of FON. Therefore, ethanol will be going to have higher boiling point because it can form stronger hydrogen bond, while methyl ether only can form weak intermolecular forces, or you can state that only can form weak van der Waals force also can be accepted. Next question, 3D. Now, Ethanol, we already draw the structure just now, has a molar mass of 46 grams per mole, which will going to boil at 78 degrees Celsius. While water, so as we already know, this is the Lewis structure for water. Okay, with a molar mass 18 grams per mole, which is smaller than ethanol, but water going to boil at 100 degrees Celsius. When we look at, okay, just now we already know that ethanol consists of hydrogen bond. Okay, water also consists of hydrogen bond because we can see there is hydrogen bonded to the oxygen. This case also hydrogen bonded to the oxygen, but why they have different molecular mass and then the boiling point are different. So that means in this case we are not going to compare with the electronegativity because both are bonded to the oxygen. So in this case we are going to focus on the number of hydrogen bonds. Since the questions already let us know water has higher boiling point, so that's why we can only mention that water will going to form more hydrogen bond. Meanwhile, ethanol form less hydrogen bond. Proceed with tutorial question number 4. Arrange this liquid in order of increasing volatility. In Bahasa we known as kemerapan, or we try to check whether the liquid is easy, escape as gas. If they are easy, escape as gas, therefore they means that they're going to have lower boiling point. So if the boiling point is higher, so the volatility will be lower. So based on the data given, we notice that ethana having the lowest boiling point, while ethanol having the highest boiling point. So when we want to discuss about the boiling point, we are going to compare the strength of intermolecular force. So what are the type of intermolecular force that presents? Means that again we need to refer to the Lewis structure. So this is the Lewis structure for ethana. So the one that with the bond and without element means that they are bonded to the hydrogen. Okay, ethanol, CH3, CH2, OH. While methanol only consists of one carbon and with one hydroxyl group. Okay, so based on here, it's very obvious that we can see that ethana have hydrogen which is bonded to ethanol has hydrogen which is bonded directly to oxygen. Same case also happen to the methanol. Therefore, we can say that both ethanol and methanol can form hydrogen bonding between the molecule. While for the ethana, even they have hydrogen over here, but all these hydrogen are not bonded to any fluorine, oxygen or nitrogen. Therefore, we know that ethanol only form when there was force. Okay. So as we know, when the was force is weaker than hydrogen bond, so that is why ethana has the highest volatility with the lowest boiling point. So then now both methanol and ethanol consist of hydrogen bond. So the next one we are going to compare will be the molecular size. Because ethanol has bigger molecular size, therefore the van der Waals force between the ethanol molecule is stronger than methanol molecule. So this is why boiling point of ethanol is the highest and therefore with the lowest volatility. Question number 5. Both ethanol and ethanoic acid are miscible. So here miscible can be, another term is soluble in water, or actually is from the word mix. Okay, able to mix with water means that they are soluble in water. Okay, but ethyl ethanol what? Only partially. Okay, partially. This one is all proportion. Okay, so explain the observation. Okay, so as we know that when we want to relate with the solubility in water, we are going to check the presence of the hydrogen bond. Because if the compound consists of hydrogen bond, it will allow them to form the hydrogen bond with water. Means that because of hydrogen bond, because of water also possess or consists of hydrogen bond between the molecule. So the molecule with the similar type of intermolecular force, they are going to mix well together. So when we look at the highlight part here, the hydrogen is bonded directly to the oxygen. This case, same case happened to the ethanoic acid. But while for ethyl ethanol, all the hydrogen are bonded to the carbon. So that's why they are partially miscible with water only, or sometimes maybe can be said is totally unmixable or with the water. Okay, so again, when we look at the how we write out the sentences during the explanation, we will going to mention ethanol and ethanoic acid able to form hydrogen bond with water. Okay, while ability for the ethyl ethanol to form hydrogen bond with water is less because they have hydrophobic alkyl group. Okay, so we call the part of with the carbon and hydrogen, okay, alkyl group. Basically, we will learn more in semester 2. So basically, alkyl group have the general formula CnH2n plus 1. So in this case, we just look at if there is a part of the structure of the compound consists of carbon and hydrogen, so it is alkyl group. Proceed to question number 6. Explain why water is denser than ice. So water is liquid while ice is in solid form. As we know, normally solid is more denser than liquid. But for the water, there is special case. So let's look at what's the reason. So generally, each water molecule will going to form tetrahedrally hydrogen bonded, okay, to another 4 water molecule, and where the structure will be looks like this. Okay, one water molecule going to form 4 hydrogen bond with another 4 water molecule. So 1 over here, 2, 3, and 4. Okay, so these cases will lead to a open structure with many empty space. Okay, here are the empty space. These are the empty space over here. Okay, so when there is a lot of empty space, so means that the volume is higher. As we know, density is related to mass and also volume. The mass is still the same, but because of the volume is high, so therefore the density will going to be lower. Okay, so this is volume of ice is larger than water, and lead ice has lower density. So that is why when you notice, even though you have a cup of the ice, if you let it melt, after all the ice are totally melted, you will notice that the volume of the ice will become smaller. The next 2 tutorial questions will be related with the metallic bond, and where we need to know how the metallic bond can be formed, and we will relate to the electron C model. And then we also need to know what are the properties of the metals And then we explain what are the factors that will influence the strength of metallic bond. And then next, going to relate the melting and boiling point based on the molecular structure in element in period 3, group 1 and also group 17. Let's look at tutorial question number 7. Describe the metallic bond for the aluminium using the electron C model. So now at here you will see aluminium always will be exist in the Al3+. Okay. And then here we can see there are 4 aluminium 3+. Okay, means that each aluminium is going to release 3 electrons, and hence here in the diagram here we supposedly have 12 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 electrons. The number of electrons cannot be more or less. So now using a wording to do the explanation, metallic bond in aluminium is an electrostatic force between the positively charged aluminium ions. In this case, in the diagram is Al3+, and the C of delocalized valence electron, because the aluminium releases the valence electron, so all the electrons in the diagram are considered as valence electrons. And we also know the electron will not be static at the same location, so that's why we will going to use the term delocalized. So again, do remember the number of valence electron needed will be tally with the number of metal ion. So let's say sometimes in the case you are going to draw the metallic bond for copper, for example. Okay, for copper using the electron C model. So if you draw 5Cu2+, means that you are going to draw 10 electrons in your diagram. Okay, and normally we are always encourage students draw more than 5 metal ion. Okay, because we want to see there is like a C of delocalized. So C here means that we can see it's very broad. Okay, so we need to show more electrons. Question 7b. Explain why the boiling point of calcium is higher than that of potassium. Okay, so let's look at here. As usual, we basically always need to identify the type of compound. This time, if the type of compound is metal, then we will follow by type of intermolecular force. We have no other choice, must be the metallic bond. Then again, we need to know what are the factors that will influence the strength of metallic bond. Okay, the first one is the number of valence electron. The more number of valence electron, the stronger the metallic bond. Okay, so another condition, if the number of valence electrons are similar, then we will look at the size, which is the second factor. Okay, and then the smaller the size, means that the stronger the metallic bond. So as here we check at here, calcium, it form ion, it will become calcium 2+. If potassium form ion, it will become K+. So in this case, calcium has stronger metallic bond. Okay, because consists of 2 valence electrons. So if we look at here, the explanation, Potassium only have one valence electron, while calcium has two valence electrons. The strength of metallic bonds is proportional to the number of valence electrons. Okay. And inversely proportional to the radius of the metal ion. So this formula you must remember. Proceed with the last question of tutorial, question number 8a. For the following substance, we have diamond, copper, and iodine. We need to arrange them in the order of increasing boiling point. So as usual again, when we want to relate with the boiling point, we must relate them with the intermolecular force. So iodine going to have simple covalent molecule. So because the formula is I2, which they are going to hold by the weak van der Waals force. While copper is a metal, so for metal they will going to have metallic bond. And then last, diamond is a giant covalent structure. Okay, and because of this keyword of giant covalent structure, so they are going to have strong covalent bond. Therefore, the boiling point of the diamond is the strongest and has the highest boiling point. 8b. Among the substance above, which one going to consist of can conduct electricity in the solid state, and they explain the answer. So as we all already know, metal always can conduct electricity. So among iodine, copper, and also diamond, copper is the one which can conduct electricity because the positive charge of the copper, for example, the Cu2 plus is always surrounded by the sea of delocalized electron. Okay, so generally we will say that from the word delocalized means that they are free moving. Okay, because the electron is free moving, therefore copper able to conduct electricity. This is the final answer for tutorial question number 2, number 3, number 4, and number 8b. Don't forget about the objective question. Thank you for staying up to here. See you in next video. Thank you.